Hello, everyone. As promised, I'm going to start my playlist Mechatronics from today, and I want to put anything I know about mechatronics in this playlist. For the first one, I decided to show you a demo on this amazing website, WOKWI, if I can pronounce it correctly, or if that's how it should be. And this is an amazing website that one of my colleagues introduced it to me. I was talking about putting a project in one of my freshman level programming classes that they program something with Arduinos. And then we were talking about that there are too many students in the class and we want small teams. I mean, like two, three people in it. So we're going to need a ton of Arduinos, right? And not everybody might be really comfortable with doing all the wirings and everything in real life, and we don't have those many hardware. If they want all sorts of inputs output sensors, we don't have basically all of those handy. And I was thinking about, is there any online simulator for an Arduino circuit and program? And he introduced this amazing website to me. So today I decided, I was working with it. I made some small demo for you that you press a push button, the LED turns on, the buzzer makes it plays a tone, a small basically buzz, and then the servo is controlled by the input from the Arduino when this push button is pressed. So for the first video, I want to show you this demo. It's really fun. So, but before that, let me show you that this website is just more than Arduino. Okay, this is a really great website. So when you get to it, it's called the world most advanced ESP32 simulator, and it's really great. I really loved it. And you can pick different kind of boards, right? You can pick different types of Arduinos. A Pi Pico is there. There is ESP32 and STM32 boards there. And basically you can write your code here, you can simulate it and so on. There are some sample projects, there is even IoT, Internet of Thing, in it, and it's really great. Okay, so you can do all sorts of things, wire them here, put the code here, and simulate it without having any physical device. If it's working, then you can put it on the actual physical device and it's gonna work. So for instance, let's say I want to put something on Arduino. So I go here, say Arduino, and then it allows me to basically pick the Arduino board that I have. So let's say it's an Arduino UNO. I go there, and as you can see, it starts a program for me on the left, and this is the setup program, this is the loop program, this is where you do the code one time, like setting up the pins, starting something at low, at high, stuff like that. And here is the stuff that you do repeatedly, and this is your Arduino board. And then, of course, you can type any type of code that you want here. And if you want to add hardware, you simply click on this plus. And here you see there are basic things like LED push button resistor. You have more advanced displays here. You see there are all sorts of 7 segments, LCD display, and so on and so forth. Then you go to inputs. There are all sorts of switches, IR sensors, rotary encoders, pod. And then you go down, there is more ultrasonic photoresistor. It's amazing. And then there are outputs like servos, like buzzer, like stepper motor, like relays. There are breadboards if you want to not directly wire them to the Arduino, you want to wire them through a breadboard. Maybe in one of my future videos, I show you one with breadboard. And then there are all sorts of miscellaneous. There is even, you can make a custom chip. You can have micro SD card, put text in it, put all sorts of logic gates, and this is amazing. All of this hardware for simulation are available to you without paying a dime. Okay, and then here you can do other things for viewing. And when your code is ready, your circuit ready, you're gonna click on the simulation. It compiles the code, and if it's working, fine, you can start the simulation and do whatever you want it to do. Otherwise, it gives you error of compiling, and it shows you where there is a bug, so you go back and fix it. So it's really great, right? And Before I go to this more advanced thing that I wrote here, so let's say, for instance, I want to add LED, right? So I go here, then click on LED, and boom, the LED is here. And now let's say you want, you see when you click on it, right? So look, you can change the color of LED as well. So there are other things you can do. And if you want, you can flip that and you can rotate that component and you can delete it. So there are all sorts of things that you can do. So let's say here the cathode goes to the ground. So I click here on this one and then I click on the ground. Boom, it's wired to the ground. And let's say the anode is coming from pin 12, right? So I click here and then click on pin 12 and now it's ready. So as soon as I send a high signal to this digital pin 12, LED will turn on, and when I put it to low or 0 voltage, then it goes basically off. Now, if you do that with a resistor, or if you do it with an internal pull-up resistor, these are different things that we'll talk about later. So if you do the pull-up resistor, then you have to give it a low signal, okay, to go high, and otherwise you give it a high signal to go basically off. So we're going to talk about those ideas separately. But here, that is basically a single element that is added just like that. And as I said, you can bring any other thing that you want, and you can simply wire them like this. Okay? So you see that bringing elements is so easy. Now, if you need to add a library, because for instance, running a servo needs the servo library. So the way you add it is you go here under library, right? And you say, I want to add the library. What library is that? That is the servo library, right? So you search for it. And if you go down the list, you can also find it. So you just click here and now the servo library is added. So since it's added to your project, then now if you say here include servo.h, it's not going to pick on you. If you don't do that, of course, it says, what are you talking about? I cannot find the file. So you have to add the libraries as well. And then some of the properties of these physical components, you can change under the diagram. If you go under the diagram, then it shows those attributes of these elements that are not the part of the C code. For instance, it says, hey, the push button, the top position of it is basically that pixel location here. This is the left position of it, and the color of it is green. So if I don't want my push button to be green, I want it to be red, I just come here and change it to red. You see, just like that. And it changes right away, right? So you see, when I brought my servo, the servo has typically the horn of it has only one side. It's not a cross like this. But I will add that later. So I went under attributes for that servo, and I said the horn of it is a cross, and the horn color is this basically number, which is for blue. Again, you can change that to blue. So if I change this to blue, would that work? We'll find out. So let's see. There we go. You see, it does work. And you're going to save it. Okay, so you can change the attributes. Now, what attributes each physical part has, that's, you can easily click on this one time. It brings this question mark. You click on that, and then it takes you to the help page for it. So it says, hey, it has three wires, right? One is the high signal, one is the low signal, one is the PWM. And then for the horn, under attributes, you can make the horn single, you can make it cross double, and the color of it you can provide. And here it shows you that this is like a single, this is a blue color, this is a double, this is a cross. Okay, so any one of them, let's say this one here, again, you can go under the help of it, and it says, hey, I can play the sounds in smooth mode or in accurate mode, right? It talks about that. And then I can make the volume anywhere from 0.01 to 1, very low or very high. And it sometimes even has a code for it. So it says, if you want to play this on pin 8, so pin 8 is the pin connected to your buzzer, then you can give it basically the frequency of that sound, and you can give it the duration. So it's going to be in hertz, and this is going to be in basically milliseconds. Okay, so you can do and play that. So this has relatively good help, I would say. For the small software it is, it's relatively beautiful. So you can see the libraries, right? You can see the diagram and change those kind of thing. And of course, you can see basically the sketch here and the code. And as I said, once you click on any of them in the beginning, right, when you bring it here, so let's say if I bring a pod, so here, if I bring this pod here, right, and I click on it, so if it allows you to rotate it or something, you should have the option here. So you see, when I bring this guy and I click on it, it does not give me the option to rotate it around, but you saw that if I bring a push button, right, look here, the push button, it allows me to rotate it, it allows me to change the color for it, and it even allows me to have a bounce or not. So there are options when you bring them first in that it will give you, right? If I bring, let's say, for instance, a servo, so let's go to outputs and bring the servo. So you see it brings the servo, you click on it, it doesn't give you an option for rotation and so on. So some of them have some options, which is really beautiful. So anyways, what do I have here? This is my Arduino UNO, where if you can see, I have a button for press for this one. The pin for it is pin 2. So as you can see, I have connected, if you look here, I have connected one side of it to digital output pin 2, and then the low signal of it I connected to the ground. So a low or a high signal is going to be received from this button pin number 2. The LED pin, which is an output pin, is pin 12. So again, if you can go and see, you see that the LED, one side of it is grounded, the other side is attached to pin 12, and it's actually pin 12. You see it's curved to pin 12 here, right? So you see if you move hover your mouse on it, it shows it's coming from which pin. It shows kind of like an electricity flowing through the wire. So it's really good for tracking and seeing which pin it is going to. So that is this, and then the buzzer is connected to pin 8. So one high output goes to 8, the low is to the ground. And then I have 2 analogs. So one analog is the servo pin, pin A0, which is the PWM for the servo, and then there is a ground and there is a high, and then pin A3, which is connected to the potentiometer, and it receives the analog inputs into pin 3, which you can see here. If I move it, you can see that it is actually going to pin number 3. So the first thing I do, I create my, I include my libraries. Then I define my pins that are I/O pins. So if you want, you can add some comment here by // So define I/O pins, right? This is basically the pot input value, and it is an integer. We'll talk about it. So first we do the setups, the operations that are to be done only one time. What is that? Here I start a serial communication for my analog inputs at this baud rate. We talk about this later. Then the first thing I do is I need to, right before the setup, I also need to define my servo, which is for this guy. I define a variable for it of which type servo. So you see, typical variables are integers, floats, stuff like that, right? Or the ones, some of them are constants, by the way. And this pot pin and servo pin, these are constant pins too. So I would rather add a constant to them because they are not going to change during the operation. It's only the variable from the potentiometer that is going to change. So I would just call them constant integers. But here, when I create this library, now I can define this class of variables called servo. So this my servo is a servo object. Now, what do I say? I say attach. This is basically method for this object, my servo. It's called attach. So attach that servo to which pin? To the servo pin. What is servo pin? Pin A0. So I say, hey, the signal, PWM signal for it is coming from pin 8. Pay attention, pin A0. Pay attention to that. And by the way, the pin mode of that servo pin is output. It is sending signal out because they can send in and out. Most of them are I/O, or all of them in this case. Then what? For the push button pin, go ahead and make sure the pin mode for it is input and then underscore pull up. So it reads the signal from this push button, but with a pull up resistor, with an internal pull up resistor. For LED, it's an output. For the buzzer, it's an output. And then initially, go ahead and digital write. This is what you do for a digital pin, whether it's input or output. Now, in this case, since it's write, it's an output. So say, hey, digital write, go ahead to the LED pin and set it to low. So make sure in the beginning the LED does not turn on. Okay, do not turn LED on. By the way, I just remembered in the beginning I said that the LED is attached to a pull-up resistor. That's my bad. I apologize for that. It's the basically the push button that is attached to pull-up resistor, not the LED. Okay, so I just remembered that I said that. It's not. LED is directly attached with no resistor or nothing in between. So low means don't turn it on, high means turn it on. It's this guy that is attached with the pull-up resistor. Okay, the push button. So just correcting for that. Now you see here I said in the beginning, make sure before anything is running, make sure that the LED is off, and then the buzzer has this command no tone, means don't play any noise on it. So mute it in the beginning. Then what? Now do this stuff in the loop. What would you do? The first thing you do during the loop is go ahead and read the potentiometer value. This is an analog pin, so you do the analog read command, read the analog, call it val, and this value from potentiometer is an integer between 0 to 1023 or 2 to the 10 minus 1, right? So read that number. Now we want to, based on that value of the potentiometer, we want to turn this servo, and the servo can only rotate from 0 to 180 degrees. So go ahead and map that value from input range of 0 to 1023 to the output range of 0 to 180. Okay, and since this value is integer, the angle that is here generated is going to be an integer value. And that angle, which is between 0 to 180, is now going to be passed to the servo for rotation, but not always. It will rotate if and only if this push button is pressed. So later we have to do an if else and make sure if the button is low, low means pressed. Why? Because it's connected to a pull-up configuration. Because it's a pull-up, low actually means it is pressed. It doesn't mean it's not pressed or unpressed. So if the button is pressed, if it's in the low mode, how would you read the button state? You have to read it from a digital read. So go ahead and read the digital input from the button pin, read it, and call it button state. Now, what is this variable going to be? It's basically going to be a variable that is like a low or high. If it's low, which is like a 0, then what? Then go ahead to LED pin and digital write it high, means send a high signal to the LED pin. That means turn it on. Then do not immediately turn the buzzer on. Wait a little bit. How much? 250 milliseconds. Wait. After you turn the LED on, wait for that much. Now go ahead and play on the LED the tone with 100 hertz and for 250 milliseconds. So actually I changed this so it should be 100 hertz. And then what? Now the value that you got between 0 to 180, go ahead and write it to the servo. So this my servo has another function method called write, and go ahead and write that to it. So it is going to be val degrees, not 90 degrees. In the past, the code that I just wrote before this, I forced it to be 90 now because there was no potentiometer. I added the potentiometer, so I have to update my comments. Now else, if nobody is pressing this, make sure the LED is low, make sure the buzzer is mute, and make sure the servo goes back to the 0 position. Okay, so if you don't press this, Buzzer is mute, LED is not going to turn on, the buzzer is stay here at 0 angle. If this is pressed, then it reads the potentiometer, convert it to an angle, turn this servo, and also what? Also, it will turn the LED on and it will make the buzzer play something. Of course, these two will act 250 milliseconds after the LED is turned on, as you can see right here. So you see we have the commands digital write and digital read for digital pins. And then we have what? We have analog read, which is for potentiometer. We don't use analog write, although it is really, it's an analog write that we do to the servo. But in the servo library, instead of using analog write, we created this method called write. So this write is actually an analog PWM write that you are sending. You are changing the duty cycle of it basically, and you're controlling the angle of this servo. So you see everything is set. Now let's go ahead and save it and run the simulation. First, it will compile, as you can see. If you have a bug, it is going to show it to you. If not, you see, it's running now. So all I need is to press on this. Now listen. Okay, so this one turned on after 2.25 seconds. This one started playing the frequency. Now this one did not turn. Why? Because the potentiometer was at 0 angle. So now I gotta move the potentiometer to a different angle and redo it. Look. You see, the pot turned. Now let's turn it a little bit more. There we go. You see, so that one turns as much as the pot says, and when I remove it, it is going to go back to original position, okay? So you see that? Here we go. I'm showing you all sorts of what? Digital in-out, analog in-out with 4 basically input outputs, or 5 in this case, and Arduino UNO. Did I have any physical hardware? No, but this code is perfectly working. So if I have these 5 sensors, and actuators in this case, or input outputs, and I have this board and it's connected, it's powered up, guess what? This can absolutely work. This code, you can just go ahead and run it. And this can help you too if you are making this code and you didn't write it yourself, you use ChatGPT to write it for you, it's fine. To make sure that your ChatGPT written code or any other AI code is working actually, before you connect it to any physical hardware, go ahead and do a simulation here and make sure that it is actually functional before you physically wire them together. So hopefully this video was useful to you. If you want to have fun with Arduinos and learn how to write C code and get different input outputs, sensors, actuators to work, I recommend you start first here, and then we can do the actual Arduino software and physically put the code up, upload it basically on the physical hardware and physically see that. I'm gonna do something like this with a physical Arduino in one of my future videos, but I wanted to see the simulation and the value of this amazing website. Well, thank you so much for your attention, and I'm gonna see you in the next video.